Right, welcome back. Let's do question 11b. In the diagram below, the graph of f of x is equal to negative x cubed plus 5x squared minus 3x plus d. Remember, we got the value of d in our previous question. We got that d is negative 9. Right, where d is the constant, then it's given. Then the point where x is 3 and y is 0 is a stationary point. Note that O is the origin. Right, determine the gradient of the tangent. The gradient of the tangent to the curve where at the point of inflection. Right, remember we got the value of d, so our equation now is f of x is equal to negative x cubed plus 5x squared minus 3x plus minus 9. Minus 9. D is 9. We got negative 9 in the previous question. So now they say determine the gradient of the tangent, okay, to the curve at the point of inflection. So the gradient of a curve and the curve at the point of contact, they have the same gradient, isn't it? They have the same gradient. And then remember that the gradient is what? Is the derivative. The gradient is the derivative. So we're going to derive to get our gradient of this curve. Okay? And then where? At the point of inflection. So it means we need to get the x coordinate of the point of inflection. Okay, we don't need the y coordinate now, just the x coordinate is fine. Okay, and then we're going to substitute that x coordinate into our derivative to get the gradient. Okay, remember the derivative here, which is the gradient, is what is changing. It's not constant. The gradient is not constant. It's changing. It depends on the value of x. So at this point, at the point of inflection, what will be the gradient, isn't it? So we need to find the x coordinate of the point of inflection. So how do we do that? We find the second derivative. We find the second derivative. So we get the first derivative, and then we derive the first derivative to get the second derivative, and equate this second derivative to 0. And then we're going to get the x coordinate of the point of inflection. And remember that we're not going to need that in this question, but remember that if you're asked to find the coordinates of the point of inflection, then you will have to substitute your x coordinate into the function. To find the y value, you substitute into the function. Okay, but we're not going to do this. You're not going to do that in this question. So let's do our first derivative. So f prime x is going to be 3 times negative 1 is negative 3. Then x to the power 2 plus 2 times 5a is 10, and then x, and then the derivative of negative 3x will be negative 3 there. Okay, constant, derivative of a constant is 0. And then we do the second derivative. So it's going to be negative 6x plus 10. And then at the point of inflation, this second derivative is equal to 0. So negative 6x plus 10 is equal to 0, meaning that 6x, or you can say negative 6x is equal to negative 10. Or they just 6x is equal to 10. Right, like this. And then we divide by 6 on both sides of the equation. We get that x is equal to 5 over 3. 10 over 6 reduces to 5 over 3. So when x is equal to 5 over 3, that's what? That's the x coordinate of what? Of the point of inflation. Now, what is the gradient at this point when x is equal to 5 over 3? We substitute this 5 over 3 into the first derivative. This gives you your gradient. Your derivative is your gradient. So we're saying f prime 5 over 3 is equal to, where there's x, we put 5 over 3. So it becomes negative 3, then times 5 over 3 squared, then plus 10 times 5 over 3, then minus 3. Okay, and then you put this in the calculator, you find that you're getting 16 over 3. So therefore the gradient is equal to 16 over 3. Okay, that's the gradient at the point of inflection. Right, remember our x coordinate of the point of inflection is 5 over 3, meaning that is should be 1,666 somewhere. So that will be the point of inflection. Let's say somewhere there. Okay, because we're going to need this point in the next question. Okay, we don't know the y now. Okay, it's fine. Right, so that's what you're supposed to do then. The gradient is equal to 16 over 3.